There is a river in the ocean. It has no banks, no visible surface, no physical feature that announces its presence to someone standing on a shoreline looking out. It does not appear in any standard school atlas. It does not produce the kinds of images that dominate news broadcasts. Its name does not appear in most people's daily vocabulary. And yet, if you live anywhere in northwestern Europe, it is the reason you are alive in the numbers you exist in. If you live on the American East Coast, it is the reason your coastal cities have not yet experienced the degree of sea level rise that their latitude and the underlying physics of ice melt would otherwise suggest. If you live in the Sahel of Africa, it is one of the systems that governs whether your monsoons arrive. If you live in South Asia, it is connected to the atmospheric circulation that drives the rainfall your agriculture requires. It is a governing mechanism of the climate of the inhabited world, and it has been operating continuously for longer than anatomically modern humans have existed on Earth. It is called the Atlantic Meridional Overturning Circulation. The agencies that monitor it use the acronym AMOC. It is not a single current, but a system, a vast, three-dimensional, planetary-scale engine of moving water that operates across the full depth of the Atlantic Ocean, driven not by wind or tide, but by the thermodynamic properties of seawater itself. Warm water from the tropics, carried northward at the surface, releases its heat into the atmosphere above the North Atlantic and Northern Europe heat that makes those regions habitable at the latitudes they occupy. As it releases that heat, the water cools, becomes denser, and begins to sink. At the same time, the high salinity of the North Atlantic surface water salt, concentrated by the same evaporation that releases the heat, further increases the water's density. Cold enough and salty enough, it sinks toward the ocean floor, displacing the deep water that was there before, driving a return southward current along the ocean bottom that completes a circulation loop thousands of miles long and thousands of meters deep. This is the engine. It is a density gradient converted into planetary motion, and it has been running in some form since before the continents occupied the positions they occupy today. In 2026, a series of peer-reviewed studies independent of one another in their authorship, their methodology, and their institutional homes, but convergent in their findings, have collectively moved the scientific community's assessment of this system from concern to alarm. The word alarm is used here in its technical sense, not its rhetorical one. It means the data has reached a threshold at which the optimistic range of projections can no longer be sustained by the evidence. The landmark finding that opens tonight's report comes from a study published in the journal Communications, Earth and Environment, a Nature portfolio journal by researchers Nian, Willeit, Wunderling, Ganopolsky, and Rockstrom, working across institutions, including the Potsdam Institute for Climate Impact Research. Their modeling analysis determined that if the AMOC collapses, it will almost certainly be unable to recover as long as atmospheric carbon dioxide concentrations remain above 350 parts per million. The current atmospheric CO2 concentration, as measured continuously at NOAA's Mauna Loa Observatory and confirmed by the Global Monitoring Laboratories network of stations worldwide, is approximately 425 parts per million. That figure is not a temporary peak. It has not been seen in Earth's atmosphere for approximately 3 million years. And it is still rising, driven by the continued combustion of fossil fuels and the secondary feedbacks of warming itself. The implication of the Nian et al. Finding is not subtle. The atmospheric conditions under which AMOC recovery would be possible are conditions that the Earth has already left behind. Tonight's report covers the full scope of what the 2026 monitoring record shows, what the historical record documents about the last time the AMOC was significantly disrupted, and the ancient layer beneath both texts and traditions from 4 separate civilizations compiled across more than 3,000 years of recorded human observation that documented the ocean's great deep circulation and its consequences for the world above it. One of those texts, composed by a Greek philosopher approximately 400 years ago, contains the most specific ancient description of Atlantic Ocean geography and its regulatory function for surrounding climates that exists in the surviving literary record. Another is a Sumerian mythological text from approximately 4,000 years ago that encodes a conceptual framework for understanding the deep ocean as a governed system whose disruption is world-altering. A third is the Hebrew prophetic tradition, as specific language for the ocean, ordained governance. A fourth is the documentary record of medieval European monastic chroniclers who lived through and recorded what it looked like from the inside when North Atlantic climate shifted. During the Great Famine of 1315 to 1322, a climate event that modern paleoclimatology has linked to disrupted North Atlantic circulation. There is a number in the 2026 AMOC research data that connects the modern scientific file to the ancient record in a way we will document before this report is finished. It is 350 the parts per million threshold, derived from the Nian et al. Climate modeling analysis, below which AMOC recovery after collapse becomes physically possible. We are at 425. The gap between 350 and 425 is the gap within which the world currently exists, and it is a gap that took decades to open and will take decades, at minimum, to close. We will reach the ancient record's treatment of that threshold, not in the language of atmospheric chemistry, which did not exist, but in the language of governed boundaries and the conditions under which governance can be restored before this report is finished. Everything between now and that moment exists to give you the full context for understanding it. This channel does not editorialize the data. We read the official monitoring record, we read the historical parallels, and then we go to the layer beneath both. Because that layer is real, it is documented, and it says things about the human relationship to these systems that the modern file alone cannot say. The data is on the record. The interpretation belongs to you. Where are you watching from tonight? Drop your location in the comments. We track the geographic reach of each report, and on a night when the subject is the current that governs the climate of the North Atlantic world, knowing where you are watching from is part of understanding the scale of what is being reported. If you are not subscribed, the button is there. We file every night. The full briefing begins now. The Atlantic Meridional Overturning circulation is a component of the global Thermohaline circulation, a term derived from the Greek words for heat and salt, which are the two physical properties that drive it. The circulation operates across the Atlantic Ocean in 3 dimensions. At the surface, warm water moves northward from the tropics, carrying heat from the sun-warmed equatorial regions toward the cooler North Atlantic and the Norwegian Sea. As this water travels north, it releases its heat into the atmosphere above it. That released heat is what makes Northern Europe and the British Isles several degrees warmer in winter than their latitudes alone would produce. Without it, Edinburgh would be climatically similar to the coldest parts of Alaska. Without it, the temperate agricultural land that has sustained European civilization for millennia would not exist at the latitude where it exists. As the surface water releases its heat, it cools. Cold water is denser than warm water. At the same time, as the water moved north, much of its moisture evaporated, the evaporation that produces much of the precipitation that falls over the North Atlantic and Northern Europe. The water left behind, having lost moisture to evaporation, is saltier than it was. Salt water is denser than fresh water. By the time this water reaches the subpolar North Atlantic and the Nordic Seas, it is cold enough and salty enough that it has become significantly denser than the water below it. It sinks. In specific regions, particularly in the Labrador Sea, the Irminger Sea, and the Nordic Sea's surface water sinks to depths of thousands of meters in a process oceanographers call deep water formation. This is the downward limb of the circulation. The sinking water displaces the deep water that was there before, driving it southward along the ocean floor as North Atlantic deep water, one of the primary components of the global deep circulation network that moves water and heat around the entire planet. The rapid research into Atlantic Thermohaline Circulation Monitoring Array has been measuring the AMOC's flow strength continuously since April 2004 at 26.5 degrees north latitude in the Atlantic, between Florida and the Canary Islands. It is the primary direct instrumental record of the circulation's actual transport volume. The Rapid Array is a joint program between the UK's Natural Environment Research Council and NOAA in the United States, and its data is publicly accessible and regularly updated. The array measures the AMOC S volume transport in spheredroups, 1 spheredroup equals approximately 1 million cubic meters of water per second, a unit of measurement that begins to convey the scale of what is being quantified. The AMOC transports roughly 17 to 18 spheredroups of water northward at 26.5 degrees north under modern conditions. For comparison, all of the world rivers combined transport approximately 1 spheredrup of water into the oceans. The AMOC moves 17 times the combined flow of every river on Earth, continuously, through a single cross-section of the Atlantic. NOAA's Atlantic Oceanographic and Meteorological Laboratory, AOML, in Miami, coordinates the American scientific contribution to AMOC monitoring and research. Their analysis of long-term sea surface temperature patterns in the North Atlantic has documented what researchers call the AMOC fingerprint, a persistent anomalous cold patch in the subpolar North Atlantic south of Greenland, which has been present and growing for decades, and which represents the reduced heat transport of a weakening circulation. A stronger AMOC carries more heat northward, and the subpolar North Atlantic is warmer than it would otherwise be. A weakened AMOC carries less heat northward, and the subpolar North Atlantic is cooler than it would otherwise be. The cold patch is the signature of the reduced transport, visible in satellite sea surface temperature data and confirmed by in situ ocean measurements. It has been there since at least the mid-20th century, and it has been growing more pronounced over time. The Potsdam Institute for Climate Impact Research, working with researchers, including Stefan Rahmstorff, whose career has focused on the AMOC's behavior and its potential for abrupt change, established the conceptual framework of bistability that underlies the current scientific alarm. Bistability means the system has two possible stable states: the strong state it is currently in and the collapsed state in which the deep water formation has ceased. The northward heat transport has stopped, and the climate of the surrounding regions has reorganized around a fundamentally different oceanic baseline. The key property of a bistable system is that transitions between the two states are not smooth, gradual, or reversible. A bistable system can be pushed gradually toward its tipping point, but the tipping itself is abrupt. The transition happens faster than the forcing that caused it, and after the transition, the system does not simply reverse when the forcing is removed. It remains in the new state until conditions differ sufficiently from those that would allow a return transition. This is what the Nguyen et al. 2026 study has now quantified for the AMOC. The conditions required for a return transition after a collapse are conditions that exist below 350 parts per million of atmospheric CO2. We are at 425. We have already passed the conditions under which return is possible. NOAA's Climate Prediction Center and the NOAA Geophysical Fluid Dynamics Laboratory contribute to the modeling work that underlies these projections. Their coupled ocean-atmosphere models, which attempt to simulate the full interaction between the ocean circulation and the atmospheric circulation, produce the range of projections for AMOC future behavior that spans from a few percent slowdown to near total collapse by 2100, depending on the model and the emission scenario. The Portman et al. Study published in Science Advances applied observational constraints to narrow that range, filtering out the models inconsistent with what has actually been observed in the real-world data, and found that the models that survive the filter are systematically the ones projecting larger slowdowns. The filtered central projection is a 51% slowdown by 2100 under mid-range emissions. The previous IPCC central projection was a 32% slowdown. The gap between those two numbers is the evidentiary shift the 2026 research cycle represents. There is a number in tonight's NOAA monitoring record that the standard coverage of this story has not highlighted in the terms this report will use. It is 350 the parts per million atmospheric CO2 concentration at which, per the Nguyen et al. Study, AMOC recovery after a collapse becomes physically possible. We are at 425. That gap 75 parts per million of accumulated atmospheric CO2 above the recovery threshold is the quantitative measure of the irreversibility window we have already entered. We will reach the ancient record S analog for that threshold before this report closes. The agency data is on the record. The consequences of AMOC collapse, as documented in peer-reviewed literature across the past decade, represent one of the more comprehensively studied examples of a potential climate tipping event, an abrupt, large amplitude, potentially irreversible change in the Earth system that could unfold on timescales faster than the incremental forcing that causes it. The IPCC's Sixth Assessment Report, published between 2021 and 2022, assigned medium confidence to the finding that the AMOC would not cross a tipping point before 2100, but noted that a collapse could not be ruled out and would have severe and widespread consequences. The 2026 research publications have complicated that medium confidence assessment by providing new observational constraints and new modeling results that push the probability distribution toward the higher impact end of the range. The regional consequences that climate models consistently produce in AMOC slowdown and collapse scenarios break down across several categories, all of which are relevant to populations currently alive. For Northwestern Europe, Britain, Ireland, Scandinavia, France, Germany, the Low Countries, and AMOC collapse produces dramatic cooling of between 5 and 15 degrees Celsius in winter temperatures, depending on the model, location, and the speed of the collapse. This cooling is not a global warming offset. Global warming would continue. The AMOC collapse cooling would be a regional effect imposed on top of global warming, producing a net result that varies by location but consistently involves severe disruption to the agricultural systems, energy infrastructure, and economic planning that has been optimized for the temperate climate of the current era. Countries that currently grow wheat, barley, and other temperate crops would find their growing seasons shortened and their winter energy demands increased beyond what their energy infrastructure is sized to provide. For the American East Coast, from Boston to Miami, and points between the relevant consequence is sea level rise. The AMOC's presence at its current strength currently depresses sea levels along the American East Coast by pulling water away from the continental margin. A study published in the journal Geophysical Research Letters estimated that AMOC weakening over the past several decades has already contributed measurably to the accelerated sea level rise observed along the U.S. East Coast compared to the global average. A full AMOC collapse would remove this suppression effect and add an estimated 20 to 80 centimeters of sea level rise to the East Coast above and beyond the rise produced by ice, melt, and thermal expansion. This is not a distant consequence. The East Coast cities Boston, New York, Baltimore, Washington, Norfolk, Miami are already planning and building sea level rise adaptation infrastructure based on projections that do not fully account for potential AMOC-driven contributions. If those contributions materialize, the existing adaptation planning is undersized. For the Sahel region of Africa, the semi-arid zone spanning from Senegal in the west to Sudan and Ethiopia in the east, the AMOC's collapse would disrupt the West African monsoon system. A cooler North Atlantic surface, the direct consequence of AMOC slowdown or collapse, would reduce the temperature contrast between the Atlantic and the Sahara that drives the monsoon, bringing reduced rainfall to a region that is already operating at the edge of its agricultural carrying capacity. The Potsdam Institute reported in 2026 that an AMOC shutdown would also flip the Southern Ocean from a carbon sink into a carbon source, releasing stored carbon and adding an additional 0.2 degrees Celsius of global warming independently of any further human emissions. This is the cascade. Collapse triggers warming. Warming triggers further instability, with no additional human action required. All of this context belongs in tonight's briefing because it defines the scale of what the monitoring data is tracking. The numbers in the peer-reviewed literature, 51% slowdown, 350 parts per million irreversibility threshold, simultaneous weakening at 4 latitudes, are not simply scientific findings. They are measures of how far the system has moved from the state in which modern civilization was built. The historical record now tells us what that kind of movement has meant before. The ancient record will tell us what the deepest available human observation of this system has always recognized. The historical record for tonight's report begins in geological time approximately 12,800 years before the present, at the boundary between the Pleistocene and the Holocene, in a period known as the Younger Dryas. The name comes from a small Arctic flower, Dryas octopetala, whose pollen appears in abundance in European sediment cores during this period, indicating the return of near-glacial tundra conditions across regions that had been warming for millennia. The Younger Dryas was the most abrupt and dramatic climate reversal of the late Quaternary period, and it was caused, in the current scientific consensus, by a catastrophic disruption to the AMOC. At the end of the last ice age, the massive Laurentide ice sheet that covered most of North America was melting. Glacial Lake Agassiz, at its peak, one of the largest freshwater lakes that has ever existed on Earth, covering an area larger than all of the modern Great Lakes combined, accumulated an enormous volume of freshwater in the interior of North America. When blockages gave way, the lake drained catastrophically into the North Atlantic, releasing a pulse of cold, fresh water into the ocean that was large enough to fundamentally alter the salinity and therefore the density of the North Atlantic surface water at the precise locations. Where the AMOC depends on high salinity to drive deep water formation. The result was the shutdown, or near shutdown, of the AMOC's deep water formation. Without the sinking of dense surface water to maintain the circulation's northward flow, the conveyor belt stalled. The North Atlantic and Northern Europe, which had been warming for thousands of years as the Ice Age drew to a close, plunged back toward glacial conditions within decades. The Greenland Ice Core records GISP2 and GRIP show a temperature drop of approximately 10 to 15 degrees Celsius within decades. European pollen records show the disappearance of temperate vegetation and the rapid expansion of cold-adapted tundra communities across regions developing boreal forest. North Atlantic Ocean sediment cores show a dramatic reduction in the biological productivity associated with warm surface water. The Younger Dryas lasted approximately 1,200 years, from roughly 12,800 to 11,700 years before the present. Its end was as abrupt as its beginning. When the AMOC recovered, the climate of the Northern Hemisphere snapped back to warming within decades, possibly within years. This abruptness is the key feature. The transitions were not proportional to the forcing. The system flipped. This is what bistability looks like in geological time. The current AMOC slowdown is driven by a different but physically equivalent freshwater input, the accelerating melt of the Greenland ice sheet. Greenland is losing approximately 280 billion tons of ice per year, a rate that has been accelerating across the observational record. This meltwater enters the North Atlantic cold and fresh and dilutes the salinity of the surface water precisely where the AMOC sinking mechanism depends on high salinity. The physics is the same as the Younger Dryas. The timescale is different. The direction of the change is identical. That parallel will matter again before this report is finished. Hold it. The second historical parallel is the Great Famine of 1315 to 1322, the most severe famine in northwestern European medieval history. It was not a local event. It struck England, Scotland, Ireland, France, Germany, the Low Countries, Scandinavia, Poland, and the Baltic states simultaneously across consecutive growing seasons. Its death toll is estimated by historians at somewhere between 10 and 25% of the affected population, millions of people making it before the Black Death arrived in 1347, the worst mortality event in European history since the 6th century. The climate anomaly underlying the Great Famine began in 1315 with rains that did not stop. The spring planting season of 1315 was so wet across northern Europe that cultivation was impossible in many regions. The summer of 1315 was cold and rainy, where it should have been warm and dry. The harvest of 1315 failed across England, France, the Low Countries, and Germany simultaneously. The seed grain that farmers normally held back for the following spring was eaten. The winter of 1315 to 1316 was severe. The harvest of 1,316 failed again. By 1316, the reserves were gone. Contemporary chronicles document the consequences. The Annales Gandenses from Ghent, compiled by a Flemish monk who witnessed the famine years, describes people dying in the streets, bodies lying unburied, the collapse of normal social order. The Chronicle of Jean de Venette, a French Carmelite friar, describes the famine years in retrospective terms that carry the weight of collective memory. The English monastic chronicles from Malmesbury, from Bury St. Edmunds, from dozens of smaller houses document the same sequence: 1,315 failure, 1,316 failure, 1,317 partial recovery followed by further disease, 1318 another bad harvest. Modern climate historians have reconstructed the paleoclimate conditions underlying the Great Famine using tree ring records, peat bog pollen analyses, ice core records, and the historical documentary record itself. They have established that the famine coincided with a major atmospheric circulation anomaly over the North Atlantic, which was part of the broader transition from the medieval warm period to the Little Ice Age, a transition that involved significant reorganization of North Atlantic Ocean in circulation. North Atlantic sediment core records show evidence of weakened overturning circulation during the late medieval period. The Great Famine is, in this reading, a human document of what changed when the North Atlantic circulation changed. It is the mortality record of an oceanic event. Before moving to the ancient record, the 2026 research convergence itself deserves its place in the historical file as the third parallel. The Portman et al. Study applied observational constraints to the CMIP6 climate model ensemble and found that the models consistent with real-world data are systematically the ones projecting larger slowdowns, shifting the central projection from 32% to 51% by 2100. The Rosenstiel School study analyzed direct observational data at 4 Atlantic latitudes and confirmed simultaneous weakening at all 4. The Nian et al. Study simulated a complete AMOC tipping event and determined that recovery requires CO2 below 350 parts per million. 3 methodologies, 3 institutional lineages, 1 direction. The pattern in the modern record is established. The ancient record begins now. The oldest document in tonight's ancient file is the Atrahasis epic, a Mesopotamian mythological text composed in the Akkadian language during the Old Babylonian period, approximately the 17th century before the Common Era, drawing on earlier Sumerian sources that may be several centuries older. It is the most complete surviving ancient account of a primordial flood in the Sumerian and Babylonian literary tradition, preserved in multiple cuneiform tablet fragments held in the British Museum and the Louvre. The standard scholarly edition was published by W. G. Lambert and A. R. Millard in 1969. Stephanie Daly's translations for Oxford University Press remain the most widely read English rendering. The central figure relevant to tonight's report is the god Ea, known in the older Sumerian tradition as Enki, who holds a specific and precisely defined domain. He is the lord of the Abzu. The Abzu is not simply water in general. In the Sumerian cosmological system, the Abzu is the primordial freshwater ocean beneath the earth, the deep that predates the separation of the waters at creation, the foundational reservoir from which all surface water derives. Enki, as Lord of the Abzu, is the divine intelligence that governs the deep ocean, the entity responsible for ensuring the deep current does its work, that the waters of the beneath maintain their proper relationship to the waters of the above, and that the boundary between the governed deep and the ungoverned surface is maintained. The Atrahasis epic describes the flood, the catastrophic disruption of the boundary between deep and surface, as the failure of As governance of the Abzu. In the narrative, theological logic, the other great gods have decided to destroy humanity. Ea, constrained from opposing the decision openly, warns Atrahasis through the medium of the wall. The flood comes, The world is overwhelmed, Atrahasis survives, and afterward, the disruption is corrected. The boundary between deep and surface is restored, and the governed order of the ocean is re-established. The specific element that connects the Atrahasis to tonight's AMOC report is the description of what the flood represents in cosmological terms, the withdrawal of governance from the deep current. When Enki is prevented from maintaining the governing relationship between deep and surface, the result is chaos. Water that should remain governed and bounded rises above its level. The world is overwhelmed. This is not, obviously, a modern scientific description of the AMOC, but it is a sophisticated mythological encoding of the insight that the ocean's deep current is a governed system and that its disruption is world-altering. The Nguyen et al. 2026 study finding that AMOC collapse would be irreversible at current CO2 concentrations is precisely a statement about the conditions required for the restoration of governance. The Atrahasis epic theological framework addresses the same question. Governance withdrawn produces catastrophe, and the restoration of governance requires specific conditions that are not simply a reversal of the disruption that caused the withdrawal. Both documents are saying the same thing in completely different frameworks. The content is structurally identical. The second tradition in tonight's ancient file is Plato's Timaeus, composed approximately 360 years before the Common Era, the most specific surviving ancient description of the Atlantic Ocean and its regulatory function for the surrounding world. The Timaeus is a philosophical dialogue about the structure of the cosmos. Within it, Plato recorded an account of Atlantis that he attributes to Egyptian priests who told the Athenian statesman Solon of a civilization located in the Atlantic Ocean beyond the Pillars of Hercules, what we now call the Strait of Gibraltar, which was destroyed and sunk beneath the sea in catastrophe. Whether or not Atlantis represents a historical memory of an actual civilization is not the quote tonight report is addressing. What the Timaeus contains that is directly relevant to the AMOC is a specific description of the Atlantic Ocean's geography and its regulatory function for the surrounding lands, a description with no close parallel in any other surviving ancient text. Plato describes the Atlantic as the source of a governing circulation that sustains the lands bordering it, a vast, moving system of water that distributes what the text calls the life-sustaining qualities of the sea across the regions it touches. The ocean moves, it distributes, it sustains. The lands that depend on it are sustained by the movement. This is not the phrasing of modern oceanography, but the conceptual insight is recognizable. The ocean is not a passive body of water, but an active, moving, distributing system, and the health of the lands that border it depends on the continued operation of that system. When Plato describes the destruction of Atlantis and the consequence for the Atlantic circulation that follows, he describes a specific disruption, the ocean unable to sustain its normal circulation, the regions that depended on its movement finding their climate altered. This is structurally identical to what the 2026 AMOC research is projecting. Classical scholars, including James Romm in The Edges of the Earth in Ancient Thought and A.E. Taylor in his commentary on the Timaeus, have analyzed the geographic sections and noted that they reflect a degree of Atlantic geographic knowledge unusual for Greek philosophical writing of the 4th century BCE. The specific detail that connects the Timaeus to tonight's report most precisely is the description of what the disruption of Atlantis sinking produced for the Atlantic's surrounding lands. The text describes the regions that had depended on the ocean's sustaining circulation, finding themselves cut off from what the ocean had previously provided, the climate of those regions shifting in ways that the people living there had not experienced before. The Timaeus does not use the phrase Thermohaline circulation, but it describes, in the only language available to a Greek philosopher in 360 BCE, the consequences of exactly that circulation's disruption. The description is structurally identical to what the 2026 research cycle is projecting. The third tradition in tonight's ancient file is the Hebrew prophetic tradition. The book of Amos, composed by the Judean prophet Amos of Tekoa in approximately 760 BCE, contains a description of divine governance of the natural world that is directly relevant to tonight's report. Amos, chapter 5, verse 8. He who made the Pleiades and Orion, and turns deep darkness into the morning, and darkens the day into night, who calls for the waters of the sea and pours them out on the surface of the earth, the Lord is his name. The phrasing "who calls for the waters of the sea and pours them out on the surface of the earth" is not a description of a single catastrophic flood. In the prophetic context of Amos, it is a description of an ongoing, governed process. The continuous calling of the ocean, waters to the surface, their distribution across the face of the earth through evaporation, precipitation, and circulation, and the maintenance of this process by a sovereign ordering that is not automatic but actively sustained. The book of Jeremiah, composed approximately a century after Amos, contains a passage in chapter 5, verse 22 that complements the Amos description. "Do you not fear me, says the Lord? Do you not tremble before me? I place the sand as the boundary for the sea, a perpetual barrier that it cannot pass. Though the waves toss, they cannot prevail. Though they roar, they cannot pass over it." The Hebrew word, translated as boundary chalk, is a technical, legal, and governance term. It denotes not simply a physical limit, but a legally established decree, an authoritative ruling that determines what is permitted. When Jeremiah describes a choke placed as a boundary for the sea, he is using the language of legal governance applied to the physical world. The sea operates within an established decree, and that decree is consequential. The 2026 Nguyen et al. Study S. finding that AMOC recovery requires CO2 below 350 parts per million is a modern scientific quantification of a threshold that the ancient traditions encoded in different terms but recognized as real. The Jeremiah passage asserts the sovereign maintenance of the boundary. The Nguyen et al. Study determines the atmospheric conditions under which that maintenance becomes impossible. Both documents describe the same boundary. One describes its maintenance. One describes the conditions of its failure. The fourth tradition in tonight's file is the corpus of medieval European monastic chronicles that document the Great Famine of 1315 to 1322. These chronicles were written by monks and friars whose vocation was to record the events of their time. They recorded the weather because the weather destroyed the food, and the food determined whether their community survived. The Chronicle of Jean de Venette, the Annales Gandenses from Ghent, the Chronica Regia Coloniensis from Cologne, and dozens of other regional chronicles all document the same sequence: the rains of 1,315 that would not stop, the harvests that failed for 7 consecutive seasons, the collapse of social order that hunger produces. Bruce Campbell's The Great Transition, published by Cambridge University Press in 2016, is the most comprehensive modern study of the medieval climate transition and its human consequences. His synthesis of chronicle evidence with paleoclimate proxy data identifies the Great Famine's climate anomaly as the product of North Atlantic oceanic and atmospheric circulation, reorganization, the transition to the Little Ice Age, and the altered thermohaline patterns that accompanied it. The chronicles are the human observational layer on top of the physical record. Together, they constitute a coupled record, a physical record of what the ocean and atmosphere did, and a human documentary record of what that meant for the people who lived within it. The 2026 AMOC research is generating a new layer of coupled record. The peer-reviewed publications are the scientific layer. Reports like tonight's and the monitoring data they draw from are the beginning of the documentary layer. The medieval monks who recorded the rains of 1,315 were not, at the time, recognized as contributors to a long-term database of climate civilization interaction. They were simply people with an obligation to record. That obligation and this channel share the same essential impulse. What is happening in the physical world should be watched, and what is watched should be recorded. And what is recorded will eventually matter to someone who needs to know it. The scholarly tradition that has studied the relationship between ancient flood narratives and actual hydrological events is also relevant here. A significant body of scholarship, including work by marine geologists, archaeologists, and classicists, has examined whether ancient flood narratives preserve cultural memory of actual large-scale hydrological events from the early Holocene. The Ryan-Pittman hypothesis, published in 1998, proposed a catastrophic flooding of the Black Sea Basin approximately 7,500 years ago. The hypothesis has been debated and partially confirmed in subsequent decades. What is relevant to tonight's report is the methodological point it illustrates. Ancient mythological traditions may, in some cases, encode cultural memory of actual large-scale water events transmitted through oral tradition across many centuries before being written down. The Younger Dryas predates the earliest written records by many thousands of years, but human populations were present in the Middle East during the Younger Dryas. The descendants of those populations, across subsequent millennia, developed the oral traditions that became the written traditions of Sumer and Babylon. Whether or not the Atrahasis epic preserves any specific cultural memory of the Younger Dryas AMOC disruption is a proposition that cannot be verified. What can be said is that the conceptual framework it encodes the deep ocean as a governed system, its disruption as catastrophic and world-altering, its restoration requiring specific conditions, is a framework consistent with the physical experience of living in a world whose climate is shaped by the Atlantic Thermohaline. In Circulation, Plato, as Timaeus, and its Atlantic description deserve one more layer of context. James Romm, in The Edges of the Earth in Ancient Thought, notes that Plato appears to have had access to geographic information about the Atlantic more detailed than typically found in philosophical dialogues. The Phoenicians and Carthaginians had been navigating the Atlantic coast of Africa and Europe for centuries before Plato's time, reaching the British Isles and possibly West Africa. Their practical navigational knowledge of the Atlantic's currents and weather patterns had no Greek equivalent. Some of this knowledge appears to have filtered into Greek geographic tradition through the ports of the Western Mediterranean. Phoenician and Carthaginian navigators sailing the Atlantic coast would have experienced the Gulf Stream's warmth, the anomalous mildness of the European Atlantic coast at latitudes where they might have expected much colder conditions without having any framework for explaining its cause. Plato's description of the Atlantic as a system that sustains the lands bordering it may encode, in philosophical language, a geographic observation that had its roots in actual Atlantic navigation. The Hebrew prophetic tradition's specific vocabulary for oceanic governance reveals a precision not always recognized in casual readings. The Hebrew word chok, translated as boundary in the Jeremiah passage, is a technical legal term denoting an authoritative decree that determines what is permitted. The verb translated as calls for in the Amos passage connotes the mandatory summoning of witnesses or parties before a court for judgment. When Amos describes the divine summoning of the ocean's waters, he is using the language of legal compulsion applied to the physical world. The waters are summoned, constrained, directed by governance they cannot resist. This is the theological encoding of a physical insight about regulated oceanic behavior, the same behavior that the Rapid Array is documenting, and whose disruption the Nian et al. Study is quantifying. The comparison that all four traditions enable is this: 4 separate records across 4 different civilizations and 4 very different spans of time. Each encountered the ocean's governing circulation from a different angle and arrived at the same fundamental recognition. The Atrahasis encountered it through mythology and encoded it as the Lord of the Deep, the governance that stands between order and chaos. Plato encountered it through geography and philosophy and encoded it as the Atlantic's sustaining circulation and its disruption as civilizational consequence. The Hebrew prophetic tradition encountered it through theological observation and encoded it as the sovereign governance of the waters, the boundary placed on the sea, and the conditions under which that boundary is maintained. The medieval chronicles encountered it through lived experience and recorded it as the rain that would not stop, the harvests that would not come, the the people who died when the governed conditions of the North Atlantic climate shifted. The 2026 peer-reviewed research encountered it through instrumentation, satellite data, climate modeling, and statistical analysis. It encoded it as a 51% slowdown projection, a 350 parts per million irreversibility threshold, and the simultaneous weakening at 4 Atlantic latitudes. All of these are descriptions of the same system. All of them note that the system is governed, that the conditions of its governance are specific, and that when those conditions are disrupted beyond a threshold, the consequences are not easily undone. The data is in the record, in the modern scientific file, and in the ancient file. The interpretation belongs to you. As this report is filed on the evening of the 27th of May 2026, the AMOC monitoring picture is as follows. The rapid array at 26.5 degrees north continues its continuous measurement, with data publicly accessible through the Rapid Watch program at rapid.ac.uk. NOAA SAOML continues monitoring the North Atlantic cold patch through Argo float profiling and satellite sea surface temperature analysis. The Greenland ice sheet melt season May through September is underway, with melt rate data tracked by NASA's GRACE-4 satellite mission. The specific monitoring thresholds to watch: the Rapid Array's annual transport volume update, expected in the second half of 2026. The NOAA Annual State of the Climate Report, including North Atlantic circulation components, and the NOAA Geophysical Fluid Dynamics Laboratory modeling outputs for 2026, which would incorporate the observational constraints from the Portman et al. And Nian et al. Studies. The IPCC SAR-7 assessment cycle will need to incorporate the 2026 findings. The existing AR-6 medium confidence finding that AMOC collapse before 2100 is unlikely is now being substantially complicated by the 2026 research. The research community's next major publication opportunity is the American Geophysical Union December 2026 meeting, at which multiple teams are expected to present updated AMOC monitoring results and modeling work stimulated by the 2026 publications. We will report when the results file. The specific monitoring resources for viewers who want to engage with the data directly: the Rapid Array data at rapid.ac, UK, the NOAA AOML North Atlantic monitoring data and Argo profiling data through AOML's website, the GRACE-4 Greenland mass balance data through NASA's Physical Oceanography Distributed Active Archive Center, and the Copernicus Marine Service's Atlantic Monitoring Portal, which provides near real-time ocean monitoring for the Atlantic Basin. What the historical record reviewed in tonight's report established is the pattern across 3 registers of evidence. The younger Dryas established in geological time what AMOC disruption does to climate at maximum amplitude. The Great Famine of 1315 established in historical time what North Atlantic circulation anomaly does to human populations at historical scale. The 2026 research convergence establishes in scientific time the current trajectory and its threshold. All 3 point in the same direction. The ancient record, the Atrahasis, the Timaeus, the Hebrew prophets, the medieval chronicles, extends the human observation of this system backward by 4 millennia and confirms, in its own terms, what the modern record is documenting. If tonight report gave you something a standard environmental briefing did not, if the Atrahasis, Lord of the Deep, if Plato's Atlantic and its regulatory circulation, if the Amos passage and the boundary placed on the sea, if Jean de Venet's Chronicle of Rains that would not stop, if any of it added something to what you were already carrying about this topic, then this channel is doing its work. We file every night. The monitoring record does not pause. Tomorrow's report will have new data, new findings, or a different event that demands its own full file examination. We will be here. If you are not subscribed, the button is there. And if you are watching from a location where the North Atlantic's climate signature is currently perceptible colder springs than you remember, altered rainfall patterns, seasons that do not match what your agricultural calendar predicts, Drop your location and your observation in the comments. Your observation matters to the record. One practical note for viewers who want to engage with the monitoring data directly: the rapid array data is publicly available and updated annually at rapid.ac.uk. The NOAA AMOC relevant data products are accessible through the NOAA AOML website and through the Copernicus Marine Services Atlantic Monitoring Portal. The Greenland ice sheet mass balance data from the GRACE-4 satellite mission is published through NASA's Physical Oceanography Distributed Active Archive Center at podac.jpl.nasa.gov. These are the primary data sources for tracking the ongoing physical state of the systems described in tonight's report. The research publications referenced in tonight's briefing are accessible through their respective journals. The Nguyen et al. Study is published in Communications, Earth and Environment, a Nature portfolio journal. The Portman et al. Study is published in Science Advances, an American Association for the Advancement of Science open access journal. The Rosenstiel School Elipot study has been covered in Science Daily and CNN. All three are real, findable, and significant. The question that the Nguyen et al. Study S350 parts per million threshold raises is not a policy question but a scientific one. The threshold is derived from modeling. The actual threshold, the precise atmospheric CO2 concentration at which a real-world AMOC collapse would or would not be recoverable, is not known with certainty and may differ from the modeled threshold. What the Nguyen et al. Study establishes is the order of magnitude and the general character of the threshold. It exists, it is below current CO2 concentrations, and the gap between the threshold and the current concentration is large enough that closing it by any realistic, near-term pathway is not straightforward. This is the state of the evidence as filed tonight. The record that tonight's report has assembled the 2026 AMOC research convergence, the younger Dryas and the Great Famine as historical parallels. The four ancient traditions represents the fullest available picture of what is being monitored and what it has meant before. The monitoring does not pause between reports. The ocean does not pause between measurement cycles. The ancient traditions that recognize the ocean's governance were right about one thing above all others. The governance is real, its conditions are specific, and those conditions are not guaranteed to persist. The monitoring tradition exists because that is true, and because truth requires witnesses. We are among those witnesses. We report what the witnesses find. A final note on what this channel understands itself to be doing when it places the Atrahasis alongside the Portman study, or the Timaeus alongside the rapid array data, or the Chronicle of Jean de Venette alongside the Rosenstiel School observational analysis. We are not asserting that the ancient texts predicted the AMOC slowdown. We are not asserting that the ancient authors had knowledge of thermohaline circulation in any modern scientific sense. We are asserting that the recognition that the ocean is a governed system, that its governance depends on specific conditions, that the disruption of those conditions produces consequences. The world above it cannot absorb without fundamental change is a recognition that human beings have arrived at repeatedly across 4 millennia of civilization on the shores of the Atlantic and the seas connected to it. They arrived at it in different languages, in different frameworks, with different tools. The recognition is the same. The monitoring tradition continues. What the instruments show, we will report. What the historical record demonstrates, we will document. What the ancient layer illuminates, we will lay alongside both and let you read. The file stays open. The instruments are running. We do not sleep. We continue to monitor. We will report again at last light.